Okay, so you will use a calculator, but not now. Okay, so the first thing I want you to do is to look at these questions, these 4 questions, and I need you to estimate these answers. The reason why I need you to place this answer, to know these answers, well, I mean, to estimate, not, I don't need you to be very accurate, but if you look at the instruction, I said be like plus or minus 1 accuracy. Now think about this. What's log 10? 1, right? Log 10 is 1. What do you think about log 7? Sure. Okay. At least you're not telling me 70, or you're not telling me 7. So 0.7 would be a fair guess. So I want you to think about this. I want you to think about, all right, where should this number be? And you would say, well, you know, log 10 is 1 and log 1 is 0. So log 7 should be somewhere in between. That's the logic. Okay, see if you can guess what's the natural log of 5. All right, just to give you a little hint. What's the log again? I mean, what's the E? 2.7, right? And what's E squared? Around 7.4. So that means natural log of 5 should be around where? 1.5 would be fair. 1.5 would be very fair. Okay. Yes, we will use a calculator, but that doesn't mean you just let go of your brain and say, all right, I'm not doing anything and just let the calculator do its thing. No. Because you use a calculator, your brain becomes even more important to assess the validity of your answer. What would you say about log base 2 of 10? Around 3.5-ish, sure. 3.5, 3 point something. I like it. I like it a lot. What about log base 4 of 30? 2.2, sure. All right. So I hope you understand where these estimates come from. These estimates, it's based on our understanding that, oh yeah, log 7, it's slightly less than, well, the 7 is less than 10, so therefore 0.7. Okay, log base 2 of 10, you're like, oh yeah, I know log base 2 of 8. These numbers must come from some sort of reference. And you need to know what reference you're using and use it to generate your answer, your estimate. And now, go ahead, use a calculator and find out what these values are. What are these values? Use your calculator now to find out these values. So log 7, so let's see how good your estimate is. Log 7 is more than 0.7, about 0.845. Okay, so 0.845, so it's close enough, all right? So again, all I'm asking is within 1 unit of accuracy. Okay, so this is a really good estimate. Natural log of 5, let's see what it is. Natural log of 5 is 1.609. So 1.609, that's pretty darn close. Okay. And log base 2 of 10, let's take a look. Log base 2 of 10. 3.322. 3.322, that's also pretty close, not bad. And log base 4 of 30. Log base 4 of 30. Okay, 2.453. 2.453. All right, now, I want you to understand that this is the difference maker. And the fact that you are using a calculator with the knowledge that you know what you're looking for, what you are anticipating, that's a difference maker. Some kids, they use a calculator and they just abandon their brain. Those I call the misuse of calculator. You are using calculator because the numbers are kind of funky and we need some help. But that does not give away the thought process of you knowing approximately what the values are. Like as in chemistry, for many of you taking chemistry right now, yes, you would use a calculator to find out the number of moles if you're given the grams. But that doesn't mean that you just give up your brain and say, oh, whatever the calculator says, I'm going to go with it. You should still look at the number and say, does the number make sense? Okay, so that's a very important thing. And we are going to use this skill later on today, all right? Well, actually, very soon on the next question.